All right, you've touched on it in grade 11. Let's just review so that we can do some of the more complicated questions in this equilibrium unit, specifically about acids and bases. Um, Three types of, let me get my pen ready. All right, there we go. It's either acidic, basic, or neutral. Yes, something can be acidic because it's got H3O plus ions in it. Something might be more basic because it's got a majority of those, or if it's neutral, if these are two things are equal, and that's what we're trying to sum up here. Remember that a hydronium ion is this guy, and the hydroxide ion is that guy there. Okay. Its pH scale is a number scale. It goes from 0 up to 14. It is a log scale, which means it makes tiny, tiny numbers normal, or it makes really huge numbers normal. And in this case, I'm dealing with really small numbers, really tiny concentrations, and I don't want to keep writing really tiny numbers with things like times 10 to the minus 10. I want to normalize this, so I use a log scale. It's based on the self-ionization of water. If I just have a beaker of water, two water molecules can react in an equilibrium to form a hydroxide and a hydronium ion, and it's neutral if this is equal to this. And at 20 degrees or 25 degrees Celsius, pure water, these concentrations are 1.0 times 10 to the minus 7, and that's kind of where the 7 comes from as neutral in the pH scale. Yes. The 7 is coming from here, and we'll see it in a couple of questions in a second. I talked about it here. 7 plays a part in indicating neutrality. Here's a formula. H3O, concentration H3O plus is equal to 10 to the negative pH, or we can write pH is equal to negative log concentration of H3O plus. That's what this is, kind of like says it in words, but this is more of a formula look at it. So what's the pH? So if the concentration of H3O plus is given to me, I'm just going to plug this in. It's the negative log of 1 times 10 to the minus 3. When I plug that in, I get negative of negative 3, which is 3, which is less than 7, and therefore acidic. Next guy, here it's asking what is the concentration, so let's be careful here. So pH is equal to the negative log of H3O plus, and since this is 2.57 is equal to negative log of that concentration. I'm going to bring the negative sign over first because I want to get log all by himself. Now, don't go canceling out log or dividing by log. Log is like sine, and so therefore you need to get rid of it. You need to inverse sine or second function sine on your calculator. So I'm going to inverse log negative 2. Sorry about that. Let's clear that. I'm going to inverse log negative 2.57 and hit that, and I'm going to get that the concentration of H3O plus is 0.0269 molar. Okay. I plugged it into my calculator. I went second, then I hit log, and then I put in negative 2.57, and then I hit enter, and I got that number right there. So make sure you use the log function properly. Now, it would be horrible if there was a pH scale, H meaning kind of representing H plus, even though we talked about never having H plus and it always being H3O plus. It would be terrible if there was a pH scale and there's not a pOH scale, but yay, there is. It's kind of the opposite of the pH scale. Here's a very important relationship. 1 plus the other is equal to 14 in a solution. So here it's asking for what are the hydronium ions and hydroxide ion concentration of the solution prepared by adding 1 ml of 1 molar HCl. So I've got 1 molar HCl and I've got 1 milliliter of it. Yes? And I'm going to put it into 9 milliliters of water. Yes? So what am I doing when I add in 9 milliliters of water? I am diluting the HCl. I know its original concentration. I need to know its final concentration. I'm going to pull out C1 V1 equals C2 V2. Original concentration is 1. The initial volume is 1. Some people will be concerned I'm working in milliliters, but as long as my volumes have the same units on both sides, I'm okay. I'm interested in what the new concentration is, and the new volume is going to be 1 plus 9, which is 10. So C2 is going to be 0.1 molar. So that tells me that if I look at this reaction here, HCl plus some water, yes, giving me H3O plus some Cl minus. If this is 0.1 molar and it's a strong acid, it's going to completely break apart. Means I really shouldn't have 2 arrows back and forth. I should just have the 1. Means that this concentration will also be 0.1 molar. And now I can use the formula pH is equal to negative log concentration of H3O plus, which is negative log of 0.1, which is 1. So there's my pH. I don't even think the question asks for pH. But I'm going to use it just to demonstrate some of the relationships. If the pH is 1, the pOH is going to be 13 because I know that pH and pOH have to add together to get 14. So now I know what the pOH is. It's 13. And so I'm going to use that. I'm going to use the formula for pOH, which is that guy, exactly like the pH formula, but different. I'm going to plug in my 13 is negative log of that concentration. I'm going to bring the negative over, and you have to bring the negative over first before you start logging anything. Bring it over, get it away from it. And now I'm going to inverse log both, and I'm going to get that the concentration of OH minus here is going to be 1 times 10 to the minus 13 molar. And I think that answers both questions. It asks for the H3O plus ion concentration, the OH, yes? And I did that using pH and pOH. And there's another way to do it, but that's good enough for us in this question. Just one last little thing. The pH of a solution, I can use an instrument called a pH meter. Yes, I can use indicators, and we have used indicators in our class already. We used phenolphthalein in our KSP lab. It was what made the solution turn purple. There's all sorts of indicators, and they will change different colors at different pHs. Litmus is one of them, phenolphthalein, bromothymol blue, and when you're doing an experiment, you need to know when you want the color to change and at what pH, and you need to pick the right indicator to make sure that happens. And that really gives you a look at pH and some of the problem solving.